Hello and welcome to the C++11 Beginner Tutorials by Gamer2Creator. So far we have talked about quite a bit. We've made a lot of progress. We know functions, we know parameters, we know return types. We can make our own objects. We can use comparison operators. We can do a lot. Well, now we need to talk about how do you store multiple objects together. Well, one way that we stuck some objects together was that we created a class. But what if you want several objects of the same type? Well, one way to do it is arrays. Let's say we want 10 integers. For some reason we need 10 integers. We could do int1, int2, int3, int4, int5, and we'll just stop at 5. But here we have 5 integers. This is messy. This is a lot of typing, and when you start doing arithmetic with these, it gets pretty nasty. But one way that we can shorten this and make 5 integers, we'll call this ints, is using an array. Now we have an array of 5 ints. What is an array? What does this do? Well, we have one variable that is now pointing to your array, and it's pointing to the first object in that array. Well, how do you access objects in an array? Well, on this line we've created it, and here within these two brackets we've said how many we want. Now, this only works when you're declaring your array. When you want to access one of them, you would say ints 0. This is the first object in the array. So this is the first int out of the 5 that we created. It is a 0-based index, which means that you're not putting 1 in here for the first one. You put 0. This is important to remember because this is the way C and C++ is. 0 is the first one. Now, all we've done here is we've just said, okay, the int at 0 at the index of 0. But we haven't done anything with it. We just accessed it and then ignored it, and that was it. So let's say we're going to go through and assign them all to 0. Ints 1 equals 0, ints 2 equals 0, ints 3 equals 0, ints equals 0. So as you can see, we made 5 of them, but we only access at the index of 4. That's the 5th one because 0 is the first. So we have 1, 2, 3, 4, and 5. If we tried to go to the 5th, this is a big problem because now you're manipulating memory that you shouldn't be. You've gone over the bounds of the array, and you're now messing with memory that could be important to other parts of your application and or the operating system. So if we comment this out, and we put a breakpoint right here, now we can take a look in the debugger. And here you have your ints variable, which you see here is an int of array of 5. That's the type of ints variable. It's an array of 5 ints. We can see each one of the ints inside of it is now 0. Now an easier way to to do it like this, because we're accessing each one of these one after another and doing the same thing to each one of them. Well, this is where loops come in. Loops make this very easy. So we've created our loop. We've done this before. Now, we're going to loop over our array once for each object in the array. So this is where we do less than 5. I is less than 5 in our condition. Why 5? Well, 5 is the size. And we do less than because it's actually a 0-based index. So the biggest index is 4 because there's 5 in it. So if you do less than 5, which is the size, then the biggest value of I in our loop will be 4, which is exactly what we want. So you'll be doing less than the size of your array all the time. This is going to be a very common thing for you. Now we want to access our ints at I and make it equal to 0. So this will probably look foreign to you. What, ints, 2 brackets, I don't get it. Well, every time this loop executes, it's going to come in here and it's going to evaluate this. And since I is a variable, it's going to replace I with whatever the value is. So right now I is equal to 0, and this is the first iteration. So whenever we do ints I is 0, so this is going to be like as if we said ints with a 0 in here. And that's the first object in our array. And then we assign it to 0. So if we look at ints, we can see that I is equal to 0, and int's 0 index is now 0, which is what we told it to do with that index. And the rest of these are junk values. So as we keep looping, I is equal to 1. Well, here's the index. We haven't assigned anything to it yet. And now we've accessed int 1 equals 0. And it'll keep doing excuse me. It'll keep doing this until we get to I4, in which case that will be the last loop, the last iteration. Because we then increment I again. If you watch right here in the value, it's now 5. So 5 is not less than 5. That's false. And we exit the loop and return back to the function, to the scope, the shallower scope. So now that we've done that, we can also do something even more interesting. We can assign these a random number. Instead of just assigning them 0, we'll give them a random number. And we'll step through and see it working. If we expand ints, we can see all 5 of our ints. And we go over and they all get assigned a random number as we go over it. So this is basic arrays. Now this is a constant size array. We know this size as we are programming. And at compile time, we have defined the size. If you wanted to create an array of a size you only know at runtime, you would have to use the heap. You'd have to use new and pointers and some more stuff that we haven't talked about yet. But it's still basically the same. It's still an array with a size that you can loop over using an index. And you don't have to use a for loop, but this is why the for loop has this information in it. Because you will commonly need an index to access an array, and then you do some operations with that array index. Then we can even, now that we've assigned it a random, we'll square it. We'll times it by itself, just for fun. And we'll prove that this, excuse me, this is going to work. And every time it's going to access the exact same ints. So we're on our first iteration. We just assigned the index 0 int to 14,929. Now we're going to multiply it by itself, and now we squared it. Now it's upwards of 22 million or something. And then we'll go over again. We're going to do the exact same thing to that one. Now you can also, and if we keep going, blah blah blah, it does it to all of them. Now you can also, you don't have to do this in a loop. You can do this any way you want. We can do ints 0 equals 0 down here. And we're going to let the loop run. We're going to run the program. It's going to run the loop. It's going to come down here. And now all of our ints will have been assigned a random number and then squared. Then we're just going to access index 0 just all by itself outside of a loop and assign it 0. So in the debugger you can see right now it's about 22 million or something. Then we step over, and I clicked the wrong button, sorry. So we're in this position yet again, and we've got about 23 million or something. And we step over, and then 0 is placed into ints of index 0. So you can access these individually, or you can use them in loops. You can assign one object in the array to the other. So let's assign ints 0 to 22. And then we can take ints 4 and make it equal to ints 0. And let's put a breakpoint right here. So now that we're here, we've initialized our ints up here. We're going to assign 22 to the first index, which would be index 0. Now we do that. So now 0, index 0 is 22. On the next line, we intend to set index 4, which is the last index, to the value that's in index 0. As you can see, we've done this. We've taken the value from this one and put it in this one. And this is basically arrays. This is how it works. Now you're not limited to integers. We can use our employee class, and we can say, okay, employees, and how many employees do we have? Well, let's say we have a maximum of 100. Well, for the purposes of this tutorial, let's just say 5. But you could make this however many you want. You could have 1 billion of them if you wanted to. That would be a lot to put on the stack. More on that later. So now we have our 5 employees. Now they haven't been initialized, so let's loop over each one of them. And we're going to use functions now. We're going to say the employee at our loop index is equal to get employee from console. And this should be an S. And that doesn't need to be there. So what this is going to do, this is going to loop over 5 times for each employee, and it's going to call get employee from console and then assign it to the information it got from the console. So let's do this. We're going to run this, and it's going to be a lot of typing. So first name, I'll just put blah blah blah, blah blah blah. I'm just typing in junk so we can see this. Type in one real one, 27. And then the last one, I'll just say, I don't know, Bajarn, strip. I don't know if I got that right. Let's just say, I'll be nice, call 45. Yeah, he probably makes a lot of money. Alright, so where we are, we're on the send.get line. We've made our employees, or we made our employee array. We've looped over for each employee in the array and got an employee from the console and assigned it to that employee index. So as you can see here, here's our employees variable, and it's of type employee of 5. So we have 5 employees here. Now we can look at each index, 0, 1, 2, 3, and 4, and look at the data in each one, with the first name and the last name and the age and the salary. And let's go to the one that Bajarn. First name Bajarn, last name Stostrup, age of 45, salary 75,000. So we filled out each one of these by looping over the array and getting them from the console. Now we can also do the exact same thing with our loop over it again, and say, excuse me, print employee to console, and then we'll do employees by and here we're going to print out every single one of our employees. But to make this easier, I'm going to lower it to 3. We have a maximum of 3 employees. And I'll put me in there. And then the last one, and then it's kind of hard to see, but right here we stopped putting in information and it started printing them out. We have Chris, we have Bajarn, we have Sam. And if you can see this happening, that line by line we've looped over each employee and we've entered each employee's information. This code right here between these two for loops is functionally equivalent to going through on each one individually and with a lot of typing doing it all manually, calling all these functions and writing all this code all by hand. These loops are doing this. If you were to unroll the loops and do it manually, this is functionally what they're doing. But imagine if we had 100 employees and we wanted to print them all out. You would have to write a line like this 100 times in your code. Instead, you can do it in a loop for each employee and only write one line of code, but you have to understand how to use the index of your loop to access a particular object in the array. So we'll go ahead and run this just to be sure that it's working. And there we go. We can see this doing functionally the exact same thing, but with a lot less typing. And you can see how the more employees we have, the more important the loops become. And they're kind of like functions in that once you get the code working inside the loop for one of its iterations, it does the exact same thing for every iteration. So like a function, you can use it in order to save yourself from writing a lot of code. And a lot of code means a lot of opportunity for introducing bugs and problems and typos and whatever. So loops are a very important part of programming, and you'll end up using them all the time, and it will become second nature. Just remember that you will do less than its size. And often, one more thing I want to cover real fast, and we're going to remove this and we're going to use the loops, is that here we've been using just the number 3. Often you'll do something like this, a constant int. We haven't really covered constant yet, but just know that it means this variable will never change. It's constant. The value of it is constant. So constant int array size equals, and we'll say 3. Now that we have our array size variable, we can replace these 3's with array size and in our loops as well. And you can see where instead of just using the number 3, we now have a variable with a name that we can use. And the name makes sense. It tells us how many objects are in the array. And we use it when we declare our array, and we also use it when we loop over it. And you can just imagine the number 3 being replaced anywhere where array size is. This also allows you to change how many are in the array just by changing this one number. Now we have 30 in the array, and our loops still work. You can have 300, 3,000, whatever, however many you want. But using a variable and passing this variable around allows for cleaner code, and it makes more sense whenever you loop over it. It's more descriptive. But I need to make it very clear that when you make an array like this, you have to use a constant integer whenever you create your array, because you have to define the size at compile time, and that must be a constant for that to make sense, because whenever the code compiles, it's going to create enough space for whatever your array size is. If it's 20, then it's going to create enough space for 20 employees, and it's going to do this within this function. And these have the lifetime of this function, just like any single variable, and they will all be freed when the function ends. So remember, it must be a constant int, or a long int. Just as long as it's constant and it's an integer type. And real quick, I'm going to switch out the employee code with int code, just so that you can see it. Just another example. Int my ints. And see how much the code really is the same. And then we don't have a function to print ints, but it's really easy to write. Count. And we have our get int from console function. And so now this code is going to work just like our imp code did on a functional level. So we have 5 ints now in our array. And if we run through it real quick in the debugger, we can see that we have my ints is an int of 5. It's an array of 5 ints. And we have array size is 5. And these have not been defined yet, or declared, or initialized. They are full of junk numbers. So I'm going to move our breakpoint down, and now it's going to want us to put in 5 ints. So we're going to put in some ints, and there's our 5 ints. Now we're on this line. We've looped over our ints, we've got them from the console, and now we're going to print them out. We've printed one of them out, and I made a mistake. This is interesting though. This is a very interesting thing, because we printed out the value of my ints, but not one of the actual ints inside of the array. So it actually printed out the address of our array. What we needed to do was grab one of the objects within the array. So let's do this again. And I'm glad that mistake happened, because that was important. So where are we? Okay, so it needs me to put in 5 ints. Now we've done that. We've gone through this loop. Now we're going to go through this loop. As we can see, now we've printed out the first one. And 1, 2, 3, 4, 5. Now we've printed out all 5 of them. And the program is now ending. So this is arrays. This is how it works. Like I said, you'll be doing this all the time, and it will become second nature, but it does take time for your mind to adapt to this kind of repetition thinking, that you're not telling it to do each one individually, you're telling it how to do each one in a loop, in a repetitive manner. Um, and as we go along, as we get into more stuff, that you'll see more and more examples of these things, and hopefully it'll sink in. And practice makes perfect. So keep working at it.